Hello, this is Greg Allison with Galactic Greg's coming to you on the 26th of August, 2020 with a bold proposition. The proposition is that it might actually one day rain gold from the sky. Imagine that, me oh my. So the question I've got to ask you, of course you may have seen or heard the TV show that used to be on, do you want to be a millionaire? How about, do you want to be a billionaire? And in fact, could it be possible that every single person on Earth could be a billionaire? Well, I know that sounds ridiculous, right? Well, it just so happens that there's this asteroid. This asteroid is the largest metallic asteroid, full metallic asteroid we know of. It's called 16 Psyche. And 16 Psyche is made up of metal, heavy metal. And it's called 16 Psyche because it was the 16th asteroid discovered in the solar system. And in fact, it was discovered in 1852. Imagine that, 1852, long before, even 8 years before we had, 9 years before we had the so-called War of Northern Aggression here in the United States. You know, still we're fighting with muskets and mules and cannons. We were discovering asteroids. So 18, that was quite a while back. Now, the thing about this asteroid is that it is estimated that it has gold, platinum group metals, nickel, iron, mostly nickel and iron. In fact, it's thought to be the core of a protoplanet. Now, what they believe is that the solar system formed from smaller rocks and chunk pebbles that accreted into rocks and chunks through gravity and other things, and they eventually became asteroids. And as they grew, they became protoplanets, at least many of them. And these protoplanets collided and formed planets that and swept up other asteroids and such. So if you think of this as planet Earth, or if you think of a protoplanet being much smaller, once you reach a certain size, the gravity is sufficient that it will pull everything into it to a round shape, such as Earth, or the asteroids Vesta or Ceres. They're large enough that they're round. Well, this was also probably at one time a round protoplanet that got smacked and blasted and till everything was left but its core. Now, on a large planet, protoplanet, it gets hot enough that it, especially in the early solar system, these materials were hot enough that they differentiated. It's kind of like if you boil a pot of lead to make bullets. And when the heavier stuff settles to the bottom and the lighter slag comes to the top. Well, and like on Earth, we have the crust, which is the lighter rock. And the heavier materials go to the core. And so this is believed to have a core of gold, iron, nickel, and other platinum group metals. So the estimated worth of this body is 10,000 quadrillion dollars. That's a little bit of change, 10,000 quadrillion dollars. Now, if you had 10,000 quadrillion dollars, imagine that. That is $1 billion for every man, woman, and child on this planet. Now, of course, if you were to suddenly take all that gold and other metals and distribute across this planet, well, the values of them would drop. So it wouldn't be worth as much, not quite. But suffice it to say, there's lots of wealth in space. And no, I don't see us dropping this whole thing on Earth all at once, because that would be a bit catastrophic. But we may mine it. There may be ways to go there and get bits and pieces of it. So now this is an artist rendition of this body. And this is an actual photograph of it. This is kind of what the artists think it might look like. They were able to find the weight of it, mass of it, by its perturbation of other asteroids in orbit. And they found, wow, this thing must be dense. So they calculated the density of it. And then when they actually saw it, they go, oh, well, that's when they figured it must be dense. They knew it was massive. But when they actually saw the size of it, they knew it had to be dense. So that's an actual photograph of it. Now we have a probe on the way there. The probe is, you know, the Psyche Probe. And so we're going to tell you a little bit about that. But before we go into this, I'd like to say, I I'm gonna have a lot more videos. I've been a little behind on putting together videos. My life has been pretty busy, but I'm gonna try to do more videos and post them on this channel. So to get the updates, subscribe to my channel, bang the update notification bell, and click all, and that should give you notification of when I put new videos on this channel. And support this channel. Click the link below. The links below. I have links to my sister channel, Green Greg's, and that helps me in Galactic Greg's also. All right. So what I like to say is that, again, this was discovered on the 17th of March, actually, in 1852, by the Italian astronomer Annibale de Gasparis. Now, excuse me, I've been to Italy, but my Italian isn't necessarily the most fluent. But I have been there. Now, walking through the crowds, I must remember the words excuse me, which is excuse me in Italian. Now, and of course, you're welcome is prego, what we think of spaghetti sauce, right? So this is, again, thought to have formed from a protoplanet. So what we're looking at here is this probe. This probe was designed by the Jet Propulsion Laboratory in conjunction, well, actually, they led it, but it was a team from Arizona that led this thing, and the team was led by, hang on a minute, let me check this out. The team was led by Linda Elkins Tanton. She is the director of the School of Earth and Space Exploration at Arizona State University, and she presented this concept for the Psyche orbiter. So this thing's actually going to orbit Psyche, which is really awesome. It was actually intended to launch a year later than what they're planning now, but it got moved up because they found a gravity assist opportunity. So it's going to be launched in 2022, and it's going to get a gravity assist by Mars in 2023, and it should arrive by 2026 instead of the original 2030. So by 2026, we should be surveying the asteroid Psyche, 16 Psyche, which is believed to be rich in gold and platinum. So that, and it's going to be launched on a Falcon Heavy, by the way, sometime July 2022. So just a little bit less than 2 years, all things willing, this should launch. And the team was awarded $117 million by NASA to do this. So let me show you something about this. Well, actually, that was SpaceX launch contract. I'm going to end this share for a second because I'm going to show you something I'm quite fond of. These guys from the University of Arizona are quite studied in the area of asteroid mining. And in fact, they published books like this, Resources of Near-Earth Space, talking about asteroid mining. And one of my favorite authors in here is Dr. John Lewis. And you see there's other authors involved in this, editors, you might say. This is opinion. This is kind of like a textbook of asteroid mining. It's got all kind of figures, charts, mathematics. This really goes to the details, great details. This is an engineering scientific treatise on how to do this. And this book was written some old time back. Let's see what's the publication date on this book. It is, give me a second. Yeah, the other authors on this book are Mildred S. Matthews and Mary L. Gurielli. Pardon me, I'm murdering her name there. And this was copyright 1993. So they've been into this for some time. And Dr. John S. Lewis also wrote this book about the risk of asteroids and comets to our Earth, to really bring that to our attention, how their impacts could do us in. This book goes in a lot of detail on that. And that's worth knowing because one of the reasons to go out and mine asteroids is once you mine them, they're not, put them to use instead of having to hit us and whacking us and wiping us out. We can use them to make life far more prosperous than you can imagine. And this book is also written around the same time frame. I'm looking for the date real fast. Oh, okay. Actually, I think it's written 92, 93. I have to check it. Because this book was written in 94, Mine in the Sky by John S. Lewis. And this book also goes, this is something that is a little bit more layman oriented. I mean, you still want to have a lot of understanding of space, the space systems to understand this book, but it's an easier read than all the schematics and equations, all the mathematical, but it does go into quite a detailed explanation. Mine in the Sky by John Lewis. And so this is the kind of stuff that's coming out of that organization there in Arizona at Arizona State University. You know, we got a lot of resources. These are several people that have been involved in the ideas, the science and engineering of asteroid mining. So it's kind of exciting that these guys are in charge of the Psyche orbiter. That really excites me. That says we've got some opportunity. So just imagine that, 10,000 quadrillion dollars. That's 10 quintillion. More money than you or I would know what to do with. Of course, like I said, if you dumped all that in the market at one time, it would depress the prices. But that just speaks to the wealth. This is one asteroid. Of course, this one asteroid is 1% of the mass of the asteroid belt. It's also about 1% of the mass of the moon. It says the moon has about the same mass as the asteroid belt. The asteroid is by some thought to be a failed planet, but a lot of the bits and pieces got kicked farther out in space and farther into the sun, and has been over the billions of years colliding with the various and sundry planets in our solar system. And that's what we want to stop, because it's not going to be so much fun if that stuff continues to collide with Earth. So, to give you a little bit more background on this, what I will tell you is that this object is, you know, like 120 miles in diameter. It's named after Psyche, the nymph that married Cupid. Now, Venus asked for Psyche to be put to death, but Cupid appealed to Zeus, and Zeus made Psyche immortal. Thank God. So now we know that this asteroid's there, thanks to Zeus, right? Just kidding, just kidding. So there's a lot of interesting aspects to this. Let me go back to some other charts here. Let's go back. I'm going to reshare the PowerPoint. Boom, ba bang. And we're going to expand it back. I'm going to show you some other stuff here. Boom. Well, there we go. So here's a concept for asteroid mining right here. I'll minimize my picture. This is just an idea of an asteroid. Maybe it's captured in near Earth space, and there's some attachment mechanism pulling bits and pieces off, and there's spacecraft taking bits and pieces back to Earth, supposedly, or some other place in near Earth space for processing. And this is a concept for an asteroid that's captured and being moved, or a piece of an asteroid. And this has a long linear accelerator here, which is known as a mass driver, and shooting little bits and pieces of this asteroid out for fuel. And it's being accelerated by these photovoltaic rays, which are basically what you'd call solar cells, photovoltaics. And that's providing the energy. Maybe you'd have a nuclear reactor if you had to get too far out from one of these, but within the main belt asteroids, there's still a fair bit of sunlight. So that's then debatable. But the idea was that they could accelerate enough velocity to maybe make a plane change on the smaller asteroids. Bigger asteroids like Psyche, forget it. You're not doing that. No, it would take so much energy to move an asteroid like Psyche, it would be unbelievable. But you can take bits and pieces off and move it over time. And maybe the mass driver might not be the most efficient way to move it. Now, one of the things that John Lewis and his colleagues talk about in their books is to make it worthwhile to go after space resources, because a lot lift costs of space are so high, you have to have a huge return. I mean, you don't want to do a one-for-one swap. For every pound of stuff you launch into space, you get a pound of asteroid back, which, you know, typically the way we do things, you'd be getting far less than a pound back. And by the old cost of over $10,000 a pound to orbit, maybe, you know, double that to get to an asteroid or better, the cost proposition starts dramatically falling off. Well, the price of gold is accelerating so much it starts to get interesting, right? All these things said, it looks like, you know, he was working up concepts for things like aerobraking, where you would have a shield that would, or a balloon that would inflate as the asteroid would come through part of the Earth's atmosphere and slow it down, so you wouldn't have to use fuel to slow it down, which means you wouldn't have to carry as much fuel up there in the first place, which might not be a problem if you're using the asteroid as fuel. But you don't want to use too much of the asteroid as fuel, especially if you're coming back from the main belt. There are other concepts, though, that are interesting. They just might take more time. If I can get the PowerPoint to cooperate with me here. There we go. One is a light cell. It's a cell that functions on light pressure. And I have a whole presentation on my channel, on my YouTube channel here, about light cell. It was presented by Les Johnson about some of the experiments they're doing. Martian Spaceflight Center has played a big active role in this. This is, and so is the Planetary Society, and this is a Planetary Society rendition of a light cell. Credit to Josh Spradlin here. So they don't use any fuel, just the sun to push them, just like the cell of old. Well, you could tack with light cells and be able to come back from the main belt into the Earth orbit, but you know, you're going to be taking years coming back. It won't take as long going out, but coming back would take quite a long time, maybe decades, tacking back in. So it might be good to get mass out there, and then maybe you would want to use asteroidal mass to get mass back if you air brake. If you're just using now the good thing about a linear electric motor like a mass driver is it's going to impose and impart a very high delta V into the material it sends out. So it will make pretty efficient use of the asteroidal material as propulsion. Of course, you're queuing up gold, your powder and whatever you're using. Hopefully you'll powder the less worthy components and do some processing up there before you get back. So you might want to send some kind of processing to that asteroid, of course, to mine it and so forth. So what I'd propose is the place that you would want to splash this down or bring it back to would be the Gulf of Mexico. And the reason I propose that is because, well, we just had a SpaceX splashdown in the Gulf of Mexico. It wasn't that handy. But if you look at all the assets available within the Gulf of Mexico, if you wanted to bring materials back, it's quite stupendous. For one, there's an enormous shipbuilding and rig building industry all through here. The ship that recovered, the Dragon 2, Demo 2, that brought Doug and Bob back, was actually built right about here in Alabama. So there's a lot of shipbuilding right along the Mobile Bay and all around Louisiana, Mississippi, Texas, heavy shipbuilding, a lot of utility boats because they're working these oil fields out here. These oil fields end right in this area. It's vacant of oil fields. So this is a perfect area to splash things down because there's just not much there. So I'm going to bring you back into here and show you that what you might be bringing back. What you could do is perhaps process some of the asteroid material into a lifting body. Or maybe you take lifting bodies up and recycle them, especially since, and one of the things that might make this whole business case close is the cheap launch to orbit cost that we may be getting through Starship, which is being developed by SpaceX. But even if Starship doesn't quite succeed, the heavy booster they're building for that, super heavy, in and of itself might dramatically reduce the cost of getting there. But even the Falcon Heavy goes a long way toward that. So the space launch costs are dropping. And so these things look far more interesting today, especially with the depreciation of the dollar and the ascent and soaring prices of gold, platinum group metals. Now this is a Google Earth rendition that I took. I kind of traced 40 miles out below Dauphin Island. And I determined right at this point, you're only about 137 feet deep in the water. So if you're recovery vehicle breaks up, or your reentry vehicle breaks up, it's still within the realm that you could dive down and recover the materials. That's a good thing. So you can make it all robotic. I wouldn't be proposed all this stuff would be manned at all, none of it. But do you want to splash down that close? There's other areas over here that probably be more interesting. There's still maybe a few oil rigs around here. You know, they splash down actually right about here. That does look kind of like a ravine. Maybe you want to go over here. But the further away you go from your processing, the more you have to mobilize and move things, and fuel is expensive with boats. You know, there's some expensive with it. Now, the cool thing is, if you look at the state of Alabama, not only do we have the bays that build us, we have metalworking facilities and rocket building facilities in the state of Alabama, and all accessible by rivers from the Gulf of Mexico, readily accessible by rivers and barges. And in fact, rocket parts have been moved quite readily from the Marshall Spaceflight Center, which has a dock right about here, all the way down the Tennessee River, and then through, there's something called the 10 Tom Bigby Waterway that takes, there's a canal between the Tennessee River and the Tom Bigby River, and the Tom Bigby River has been branched out. So you can come all the way down through here to the Gulf of Mexico without having to go all the way around the Mississippi River. It's a shortcut. And you'll find there's rocket facilities over here in Iuka, Mississippi. There's the biggest rocket plant in the world, and close to Decatur in Trinity, Alabama. There's rocket facilities and capabilities all over Huntsville and Madison County. ULA is involved in these, and even our good friends Jeff Bezos and Blue Origin has quite a hand in some of this development that's going on in this area. Not to mention, there's a steel mill in Decatur. If you come up this way, there's steel mills. You come up either this way or this way. There's steel mills in the area around Jefferson County, in Birmingham. Or if you come up to Coosa, you come into Gadsden, Alabama, right here. Gadsden also had a steel mill that probably could be reactivated. So there's large metalworking facilities in Alabama. Jefferson County, the steel mills aren't so active. They still have a lot of metalworking facilities. They're here, here, and up here. And you have more engineers per capita in Huntsville, Alabama than any place on earth. More PhDs per capita. So you've got a brain trust in this area. You've got manufacturing capabilities scattered all through here, including metallurgical manufacturing and processing capabilities. You've got a river network supported, all right there next to the handy-dandy Gulf of Mexico. Couldn't beat that. And to show you the cities that I'm talking about, again, you can see Hoover and Birmingham, which is on these rivers. This doesn't show the rivers too much, it shows the highways. So you've also got a highway network. There's a railroad. There's Florence here, Decatur, Huntsville. All these are processing facilities that can run this stuff. You have a lot of university support, University of Alabama. You got Auburn University over here, University of Alabama and Huntsville up here. So you've got quite a lot of university support. You've got engineering firms out the wazoo here in Madison County. A lot of manufacturing capacity indicators, all kinds of manufacturing, including rocket manufacturing. So, and you got the shipbuilding down here. I mean, it's the perfect place in terms of manufacturing assets to develop the systems, engineer the systems, and fill them to make these things happen. And even, you know, if you want to go to SpaceX, you know, they've got their Starship facilities over in Texas, which is also in the Gulf of Mexico. So the Gulf of Mexico makes an excellent operational site for launching, for developing, and recovering of these type assets. And I just pitch Alabama because it does have the river networks and the manufacturing assets and metallurgical working facilities and the brain trust. So there's a lot available here. I'm going to stop the share again. Bang! So I'm going to talk a bit again about this whole idea. You know, just imagine this is Earth, and just imagine you have an atmosphere around it. So what you would do is you would send in an object toward Earth so that it would go into the atmosphere. It says it would have an orbit. You would, if you put an object in orbit like this, it's not the same energy as having a tight circular orbit like a space station or, you know, re-entry just before you enter. So it's less energy to go into an orbit around Earth like this, or even when you're coming in, if you could just graze this atmosphere a little bit. So that's the idea. You try to graze the atmosphere until you burn off a lot of your velocity. You keep doing that, and then you bring down the apogee. The apogee is the farthest point in the orbit. You keep doing that enough, you bring that down, and eventually you fire a motor to circularize the orbit. Or maybe you can do that enough to circularize orbit. So there's some dynamics to that. I'm not an orbital dynamicist. Yeah, my eyes are blue besides the glasses, right? So, as the Earth is, the sky, the ocean. So, this is the beauty of this is we can remove a lot of the needs to mine our own planet by mining the asteroids. Well, the asteroids are thought to have the rare earth metals that our electronics industries is sorely needing today. And there is ways devised to get energy out of space, and some of it we can bring to Earth. Some of it we could offload from Earth intentionally by doing some of the process in space before we bring it to Earth. There's concepts in space, you can inject air into a metal as you form it and have foam metal. You can make metal with longer crystals in it because it don't have the gravity that shortens the crystals as it forms. So metal could be stronger pound for pound. So you can make some very interesting metals in space to make structures for your rockets, your lifting bodies, your re-entry systems, and there's other concepts for re-entry systems that are not too complex. So in today's world and with technology, we can bring a lot of this stuff back home. And one day we might even be growing food in space. Now, seriously, carbonaceous chondrite type asteroids have the hydrocarbons and organic compounds that you would need for a living substance. You don't have to clean it up. There may be some other chemicals in there you'd have to get out and process it. But these things are potentially doable. So the good news is we have a lot of capacity. There's a lot we can do. And this whole idea that the world's too small, we have too many people, that we're using up our resources, that's all bogus. I've just done a video talking about a habitat you can live out of, make a living out of, you got almost zero footprint on Earth, and you have a standard of living commensurate to what you have here today. In the West, across all humanity can be brought up to high level of standard of living on Earth using Earth resources without really taxing the planet at all. In fact, far less than we do today. Far, far, far less. And people would actually be living better, more wholesome, healthier lives, and living at the same level of prosperity, or better. It'd probably be better, actually. Now, when you couple in it things like this, yeah, the prosperity could be awesome. Really could be awesome. We can have a very prosperous future. And with the technologies we're developing, robots, but we've got to learn how to use them. We've got to learn to use them appropriately, because these technologies could also be a threat. They're a double-sided coin. We've got to be appropriate. Now, in my buddy over at Green Greg's talks a lot about staying out of the hive. And I think that is something we need to do. We need to maintain our independence, our freedom, our self-sovereignty. So these are all things to consider, to debate, and talk about in the future. The point of this video was I wanted to show you that there is an asteroid out there, a metal asteroid that comprises fully 1% of the weight of the asteroid belt. It is huge, and it has resources that we can mine for a long time to come, because we're not bringing all that asteroid back at one time. It's worth 10,000 quadrillion dollars in today's dollars. So there is a lot of wealth in space, and that's just from one asteroid. There are many others that we probably want to mine just to keep them hitting there. They have a plethora of materials that we could use in space, to build habitats in space, free floating O'Neillian cylinder space colonies. I'll do a video on that in the future. But there's many ways we can live in space. The problem is, how do we have enough people? It's not we have too many people. We really don't have enough. That will be the problem. We want more people. Unless you're some kind of control freak. Oh, we can't control for us. I mean, that's totally unnecessary. So the future can be very exciting. It's what we make of it. Here's the key thing. We live in a society today where all our resources that are easy to get have been mined, extracted. You know, at one time you could stick a stick in the ground in Pennsylvania and oil would ooze it. Same way in the Mideast. Now we're out drilling miles down to get it offshore and other places. It's hard to get to. We're mining ores. There are so many parts per million. It takes a vast industrial infrastructure to do and mine and extract what we do to keep our civilization going. If our civilization falls or collapses, you can't rebuild that from 1800s technology. We don't get back to where we're at today. There is no return from, you know, getting knocked back to the Stone Age to where we're at today. Not with things that we do today. So that is something to think about. And that's why we have to preserve our civilization. That's why we have to find ways to survive and get along and get off this rock and get humanity spread. But it's also why we don't want to burn and tear down the civilization we live in today. We've got to find ways to make peace with each other. And the hatred that has been spread today isn't going to get us there. We've got to learn to get along. And you don't find justice by spreading hatred, by burning things. You have to find a way to reach out with love. Love dispels hate. Hate does not dispel hate. Hate makes more hate. Hate is infectious, and so is love. But love is the only thing that can truly dispel hate. We've got to learn this as a society to survive. So more on that in the future. My sister channel, Green Gregs, has covered that. Covered the technological proliferation and the risk with a video called A Nuke in Every Pot. And also has talked about the fragility of the civilization by talking about the case of a number 2 pencil as written up in the 1950s. Why, even back in the 1950s, with low-tech world we had then, it took casts of tens of thousands to actually build a number 2 pencil. You may not believe it, but you should find that video on Green Gregs. To find all the videos on any channel, just click videos at the upper left-hand side of the screen, and you can scroll down and find all the videos. They'll never all show on the playlist, but that's the way to find them. Anyway, enough of that. I've talked enough. I hope you enjoyed this video. Again, subscribe to my channel, bang the bell, click all, and again, you can support my channel by supporting my sister channel through the links below. So thank you for watching.